Hi everyone, welcome to my channel, Tutoring Test Prep. Today we'll be going over Official Guide Number 2, Advanced Math. This video will cover the Advanced Math section of the Official Digital SAT Study Guide, a preparation book made by College Board. Please support the book by purchasing your own copy using the link in the description. I recommend you complete the questions yourself before watching this video. You can follow along beginning on page 230 in your own copy of the 2023 edition. Let's get started. Alrighty, so sample question 1, this is a classic. So what we're going to do is we need to distribute this right-hand side so that it matches the left-hand side, and we need to distribute a trinomial. So you can like do this one and then kind of like multiply it by the 2 in the binomial. A couple ways you could think about it. So x squared times x, that's x cubed. X squared times 3, that's 3x squared. Now we're going to distribute that middle term. So this will be bx squared, and then bx times 3 is 3bx. And then we're going to do the last term. So negative 2 times x, and then also times 3. So minus 2x, and then negative 2 times 3 is minus 6. And let's see if there's any like terms we can combine, and we should also put it in order. Not really, everything looks pretty different. So I think we can set that equal to what it gives us, x cubed plus 6x squared plus 7x minus 6. And now it says it's true for all values of x. That means it's equivalent. So what we're going to do is called matching coefficients. So I'm going to look at the x cubes. The coefficient of x cubed on each side is 1 and 1. So that doesn't really help us. Let's try the x squareds. So the coefficients of each side are 6, and then I have 3 and b. So I can write 6 equals 3 plus b. And if a term was totally missing, that would have a coefficient of 0 on one side. And if like the coefficient is missing, like you just have x, remember there's a 1 in front of x. It's kind of like 1x. Anyway, so we can solve this equation. We subtract 3 from both sides, and we should get b equals 3, which is answer choice B, which is correct. So I want to point out a great way to do this. I think I talked about this a little bit. You can guess and check for equivalent expressions with just x's in them pretty easily using Desmos. So let's do that just to kind of show the idea. So x cubed plus 6x squared plus 7x minus 6. And then if I type in the other side, x squared plus bx minus 2, x plus 3. And see if I make 2, they're not the same. But if I make it 3, the blue perfectly replaces the red. And if I make it 7, see, they're not the same. And if I make it 9, see, they're not the same. So because there's multiple choice, you actually could guess and check on this one pretty quickly. So keep that in your toolbox. I think I have another video about that. All right, great. Okay, so this one's a little hard to read. So let me rewrite it. 16s to the 4th minus 4t squared. So the very first thing whenever you go to factor, I said this in my Ottocento factoring video, is you see if you can pull out a GCF. Do they both have an s? No. Do they both have a t? No. But they both have a factor of 4. The GCF is 4, so we're going to pull out a 4. So We're left with divide both these guys by 4 when you pull it out, and we're left with 4s to the fourth minus t squared. Now we can factor that guy in the parentheses using difference of two squares. It's kind of just an equation you need to know, unfortunately. I go over that in the Ottocento factoring video, so please go watch that if you're confused. Okay, so the square root of 4s to the fourth is 2s squared, and the square root of t squared is just t. So I'm going to make this 2s squared plus t and 2s squared minus t. Again, kind of following this equation over here. This minus, the fact that they're both squares and the fact that there's a minus sign in between them tells us that this is what we're supposed to do. Okay, so let's see. Is that an answer choice? I hope so. Yeah, it kind of looks like just a little bit rearranged from C, which is correct. You could also absolutely, to check this one, what you could do is you could, I'm not going to do it, but you could go on Desmos and make like S2 and make T3. Type in the original, then type in all the answer choices. Whichever one gives you the same number as the original is the correct answer. So you also could use Desmos to guess and check on here. Just don't pick like 0 or 1 because things will often seem equivalent by coincidence. So maybe just make S2 and T3 or something like that. Great. Okay, for this one, we can also type it in and look at the graphs to guess and check. We already did that, so I'm not going to do that again. Let's just go over the concept. So these two guys are exactly the same. So they're like terms, so we can combine the like terms. So xy squared, remember the invisible coefficient, I was just talking about this before, is 1. So 1xy squared plus 2xy squared gives you 3xy squared. So we can combine that to make it 3xy squared. This guy does not look exactly the same after the coefficient, so we can't combine him. So we just leave him as he is, plus 3xy. If I were to go further on this one, I'd probably factor or something. But you can look at the answer choices. They don't really expect us to do that. So I guess the answer is B. Let me check. Yep. And once again, you could, if you wanted to just guess and check by graphing, probably would have took longer for this one, though. I think it was super worth it for number 1, though. All right, great. Let's keep going. Okay, this one's really confusing. It says after the brake is applied, the car takes x 24 seconds to stop, during which the speed of the car is x over 2 feet per second. Okay, so distance equals rate times time. So the stopping distance is x over 24. No, that's not the rate. The rate is the speed, which is x over 2. And the time is x over 24 seconds to stop. So that gives us a stopping distance of x squared over 2 times 24 is 48. It says the car travels 165 feet from the time the driver saw the red light to the time it comes to a complete stop. Okay, so this is just telling you the stopping distance. So I think we have to use that to write an equation somehow. Let me see. Okay, so I kind of missed this part at the beginning. It's traveling at x feet per second. And the driver has a 1.5 second reaction time. So, the distance he's going to travel is rate times time. So the rate is x and the time is 1.5. So this term is 1.5x distance. So 1.5x is the distance he travels while he's reacting to the red light. And then the x squared over 48 is like the time from when he hits the brake to when he stops. That's like the actual stopping distance. So there's like a reaction time and then a stopping distance. And in total, those two things should equal 165. So we can write this equation. The distance from stopping plus the distance from reacting is equal to 165. Now, to get it to look like one of those equations, we just have to put it in standard form. So I'm going to subtract 165 from both sides. And I get minus 165 equals 0. And now we're going to clear the denominator. So to do that, the only denominator is 48. So we're going to multiply the whole thing by 48. So we should get x squared, 48 times 1.5, 72x, and then negative 165 times 48, minus 7920. And that seems like answer choice D. And let's see if that's correct. Yep, that's right. Great. They didn't really tell us what x was, so I'm not sure if there's like a good way to do this by guess and checking. I mean, I suppose you could type in those 4 equations and figure out what x is, and then like plug in x into the word problem to like see if you get 165, but like that wouldn't have saved you like any time at all, really. So I think probably doing this one by hand was better. Maybe I'm wrong. All right, let's keep going. Okay, this one's not so bad. So we're going to first put it in standard form. We got to move this guy over here. To do that, we're going to subtract x from both sides. So we get x squared minus x minus 3 equals 0. And you can use completing the square. I don't like to do that, though. I like to use the quadratic formula. So let's write down ax squared plus bx plus c. So a is 1, b is negative 1, and c is negative 3. And we're going to use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to very carefully plug all that stuff in. So we get negative 1 plus or minus the square root, negative 1 squared minus 4 times 1 times negative 3, all over 2 times 1. So that should give us negative 1 is 1. Negative 1 in parentheses squared is 1. And then that negative 4 times 1 times negative 3, that's positive 12. So 1 plus 12 is 13. And then 2 times 1 is 2. And that looks like answer choice D. Let's see if it's right. It is. I want to point out as well, you can use Desmos, just it would be a little bit of a pain because Desmos won't give you the exact answer in square root form. But if you bring a scientific calculator, you can use that. And I have a video going over that, at least for the Casio video, the Casio calculator so far. Why don't I show you guys? So you can do it on your Casio using the video I made. I like to use the TI, so I'm going to show the TI. So I'm going to plug in 1, negative 1, and then negative 3. And I get 1 plus root 13 over 2, and then 1 minus root 13 over 2. So very, very, very straightforward. Really, if you had a scientific calculator, you just had to get it all to one side. Again, go watch my video about how to do that on the Casio if you're not sure. Great, let's keep going. Okay, this one I go over in my Ottocento factoring video. We're going to use the AC method. And what tells me I need to use the AC method is there is something that is not a 1 in front, and they're not all divisible by that number. So you see there's a 2 in front. Ideally, you want to pull out the 2, but you see 3 is not divisible by 2, so that gives you a problem. So you can't do that. I mean, you can, but it won't make the problem any easier. So we're going to use the AC method. So let me, again, go watch my, I'm going to gloss over a lot of things here. Go watch my video if you get confused. Okay, so they got to multiply to AC. AC is 2 times negative 2. So it has to multiply to 2 times negative 2, which is negative 4. And then it has to add to B, which is the thing in the middle, 3. Good, so now I got to come up with 2 numbers, negative 4 and 3. I think it's 4 and minus 1. Let's check. 4 plus negative 1 gives you 3. And then 4 times negative 1 gives you negative 4. Okay, that looks pretty good. Let's see if that works. Now we're going to split the bx term into those 2 numbers. So we're going to write 2x squared plus 4x minus 1x minus 2 equals 0. And now I'm going to factor by grouping. Let's do this one and this one. And I'm going to factor out a 2x here. And I'm left with x plus 2. And for the second one, I think there's nothing in common. So I'm going to either pull out a 1 or a negative 1. I think I have to pull out a negative 1. So let's pull out a negative 1. And we're left with x plus 2. And sure enough, seems like I did a good job because I got the same thing, right? X plus 2 and x plus 2. That is a good sign. And now we just kind of put our factors together. So the coefficients form 1, 2x minus 1. And then the repeat factor is your other factor. So we're going to put x plus 2. And now we use the zero product property. So x plus 2 equals 0. Subtract 2 from both sides. We get x is negative 2. 2x minus 1 equals 0. We add 1 to both sides. We get 2x equals 1. Then we divide both sides by 2, and we get x equals 1/2. So 1/2 is our answer because the question says it has to be positive. X is greater than 0. So this guy we can chuck out. I'll just put a slash through that. Great. So once again, 2 concepts this is testing you on: AC method and the zero product property. So make sure you know how to do both those things. You can go watch my factoring video if you're still confused. I go over AC method a lot slower there. All right. On the actual test, do not do any of that for this question. Any equation we can just type in. So let's do that. 3x minus 2 equals 0. All right. Let's see. My solutions are negative 2 and 0.5, which is just the same as 1/2. And we just chuck out negative 2 because the question wants the positive one. Great. All right, let's get rid of this. Come back over here. All right, sum of the solutions. Okay, this is a little bit confusing. I'm tempted to just kind of expand these guys, but there kind of is a faster way. And what you can do is you can take the square root of both sides to get rid of those squares. And you're left with 2x minus 1 equals x plus 2. But you have to add a plus or minus. It doesn't matter which side you put it on. Why don't I put it over here? So that's kind of like a shortcut for this one. You could expand 2x minus 1 squared, expand x plus 2 squared, get them all to one side. But that would be a lot of work. What I'm going to do now is break this up into 2 equations. So positive x plus 2 And then we'll do 2x minus 1 equals negative x plus 2. So this one, I subtract x from both sides. And let's get the numbers to the other side. So I'll add 1 to both sides. And I get x equals 3. And then for this one, first I'm going to distribute negative x minus 2. I'm going to add x to both sides. So I get 3x, and then I'm going to also add 1 to both sides. And that will give me negative 2 plus 1, negative 1. So I guess divide both sides by 3, we get x equals negative 1/3. And the question wants the sum, so sum just means to add them up. So we're going to do 3 plus negative 1/3. Not going to go over how to do that fraction math. We can just use a calculator. I'm getting 8/3. That is correct. You could also put in a decimal answer, but the decimal you could mess up. So there's no way to mess up doing the fraction because the calculator will kind of do it for you. Okay, so I think it would be a lot easier to do this one using Desmos. So let's go over that. So 2x minus 1 squared equals x plus 2 squared. Okay. Tells me one of them is 3. And then it tells me the other one is negative 0.3 repeating. So let's type that in, negative 0.33333. And change to a fraction. It tells me negative 1/3. Okay, so now let's find the sum. 3 plus negative 1/3. And it tells you the answer is 8/3. Great. Yeah, probably much easier to do that one by hand. Probably lots of people didn't know how to do that kind of square root trick that I did at the beginning. This is a weird equation. I've never seen one like this before on the SAT. It's a little different. Great. Increasing at an annual rate of 0.6%. Okay. So 0.6% of the previous year. So right away, I already know, just because from doing lots of SAT questions, this is an exponential function. And there's probably nothing, doesn't seem like there's anything fancy going on with the intervals. So it's going to look like this, a times b to the x. So, I mean, kind of right away, if we see any that are not like a basic exponential function, we can cross it out. So c is an exponential function, but it doesn't look anything like this. So I think that is wrong kind of right away. And b also kind of looks wrong. You see how the t, like it's supposed to be kind of like on the outside. I think we can cross that one out too. We can revisit those answer choices if we're not sure, but let's do that. Okay, so now it says increasing at an annual rate of 0.6%. So we have to find the percent multiplier. And increasing means to go up. So we're not going to do 1 minus, we're going to do 1 plus the percent divided by 100. I don't like to do that in my head. So it seems the percent multiplier, 1 plus 0.6 divided by 100, is 1.006. So that percent multiplier is going to be your b, your growth factor. And then the a is going to be the initial value, the initial population. So the initial value of the population is 80,000. So I can write y equals 80,000. And then my growth factor is the percent multiplier, 1.006 to the x. This is exactly the same as answer choice A, just, they just, for whatever reason, didn't add together the 1 and the 0.006. In practice, I have no idea why you wouldn't do that. They're just testing your understanding. So you see this part here is the same as this. They just did 1 plus and then made the right part 0.006. They didn't add them together. So yeah, we didn't even have to cross out any at the beginning. You see, really the only one it could be is A. So make sure, I have an Ottocento video on percents. Please make sure you know how to calculate a percent multiplier. That is one of the most criminally misunderstood things going into the test. So make sure you know it. So we did 1 plus 0.6 divided by 100. If it were a decrease, we would have did 1 minus 0.6 divided by 100. Great, let's keep going. Okay, so there's kind of a lot going on in this question. The first thing is that the square root of x, I mean, you should just know this, but the implied power is 1, the implied root is 2, and power root. So the square root of x is the same thing as x to the 1/2. That's just something you should know. I mean, you can figure it out like I just did, but you might just want to memorize that square root of x is x to the 1/2. It shows up so often. Similarly, right, cube root of x, that shows up a lot. That's x to the 1/3. You might just want to know those so you don't have to think about it so much, but you can figure it out. So remember that if there's no power, it's 1, and then if there's no root, it's the second root. The square root is the second root. Great, so I can rewrite this as 1 over x to the 1/2. Now, I mean, why don't I just do this now? Why don't we rewrite this part using laws of exponents? So we can have it kind of switch sides by making the exponent negative. So I'm going to bring this guy up here, but make the exponent negative. So I can rewrite this as x to the negative 1/2 to the n. That's just a rule of exponents. You got to know that. Definitely look that up look up a video on rules of exponents if you're not sure. And now another rules of exponents tells us when we have power to a power, we multiply the powers together. So negative 1/2 times n, 1 times n is just n, so it's negative n over 2. So we're going to write x to the negative n over 2, and that is answer choice B. And that is correct. And you also could have, if you wanted to, just pick like a random number for n. I don't know, 5. And then pick a random number for x. I don't know, 3. And then you could go on Desmos and, kind of type all these in and see whichever one matches the original. That's your correct answer. You still want to know all the concepts in this question for sure. Great, let's keep going. We're doing good. Okay, 10. Very first thing, we see a square root. We're going to square both sides. The opposite of a square root is to square both, is the square operation. Okay, so we get x minus 12 squared, which is, let's see, x minus 12 times x minus 12. That should give us x squared minus 24x plus 144. And then on the right side, the square just makes the square root go away. So we're left with x plus 44. Now we get it all to one side. And I'm going to subtract x. And I'm also going to subtract 44. So we should get x squared minus x, 24x minus x, so minus 25x. And then subtract 44, we should get plus 100. Great. Now, hopefully, we can factor. So we got to add to negative 25 and multiply to 100. Okay, so I'm thinking... I'm looking at the answer choices too. I'm thinking it's like 20 and 5. So I think it's negative 20 and negative 5 because both those... let's try that. Set up my parentheses. then we'll put negative 20 and negative 5. Negative 20 plus negative 5 is negative 25. Good. Negative 20 times negative 5 is positive 100. Good. Okay, we're all set. Now let's put the zero product property. So x minus 20 equals 0. X minus 5 equals 0. We add 5 to both sides, we get x equals 5. We add 20 to both sides, we get x equals 20. And that is looking good, but when you have square roots, absolute value, just anything wacky, fractions, rational expressions, you want to check to see if there's any extraneous solutions. So if you plug in 20 into the original, you get 20 minus 12 is 8. 20 plus 44 is 64. Root 64 is 8. So that one is good. But you see when we plug in 5, we get 5 minus 12, which is negative 7. And then equals 5 plus 44 is 49. The square root of 49 is 7. So we get negative 7 equals 7. So this is no good. We don't put a plus or minus sign because we did not take the square root of both sides in our algebra. We never did that. We actually did the opposite. We squared both sides. So we don't put a plus or minus sign when we square both sides. Okay, so negative 7 does not equal 7. So that is wrong. So the only answer is 20, which is answer choice B. And that is correct. This question was definitely, I think, a million times easier on Desmos. So let's do that. So x minus 12 equals square root x plus 44. And let's see. It doesn't tell me what it is because of the square root, but you can see it's at 20. But if you're still not convinced, just type in y equals x minus 12, y equals left-hand side, and then y equals right-hand side. I go over this in my first Desmos video. And you see it just crosses at one point, and that one point has an x value of 20. So it'll tell you if you type it in separately. Typing in the 2 halves of that equation, then clicking, I don't know, that probably would have took like 15 seconds. Definitely way faster to do this one on Desmos, especially since you have the answer choices in front of you. So you can kind of be confident you didn't make a mistake. All right, great. Let's come back over here. Okay, this one, we have to clear the denominators. So you can look that up, clearing denominators. To do that, we need to first find the LCD. If you don't know how to find the LCD of rational expressions, please look that up on YouTube. There's lots of helpful videos on it. For this one, t plus 1, t plus 3, and 4. None of these factors have anything in common. They don't both have a t plus 1, they both don't have a t plus 3, and they both don't have like a 4 or a 2 or something. So they have nothing in common. So the LCD is just all of them multiplied together. So hopefully that kind of makes sense. So the LCD is 4 t plus 1 t plus 3. So once you get that LCD, we're going to multiply both sides of the equation by that LCD. So I'm going to multiply the whole thing by 4 t plus 1 t plus 3. Okay, so you see for the first part, the t plus 1 goes away, and we're left with 4 times 3, which is 12 t plus 3. And for the second one, the t plus 3 goes away, and we're left with 4 times 2, which is 8 t plus 1. And now we're going to do this last guy. So the 4 goes away, and we just get 1 times that big mess. which is just t plus 1, t plus 3. I think I did that right. Okay, so we got to start distributing and all that mess. So we get 12t plus 36 equals 8t plus 8 plus, if you FOIL that guy, you should get t squared plus 1t plus 3t, so that's plus 4t, and then 3 times 1 is 3. Okay, now we get everything to one side and combine like terms and all that, so t squared, and we got to start putting it like a quadratic, plus 12t, 8t plus 4t is 12t, 8 plus 3 is 11, and now we move those guys over to the right side. So subtract 12t. Ooh, wait, that actually works out nice. These guys go away. Oh, that's good. Okay, let's get rid of those. And now my strategy isn't to get everything to one side. Now, because the x term dropped out, I'm going to try to get the x squared by itself. So I'm going to kind of shift gears here. So I'm actually going to subtract 11 from both sides. And we get 25 equals t squared. We take the square root of both sides. And we get t equals plus or minus, got to put a plus or minus because we took the square root as part of our algebra, 5. And they want, it says t is greater than 0. It's positive. So our answer should be 5. And that is correct. Great. So we had to know a lot of things here, but the big thing that was probably new to lots of people watching this is clearing denominators. Make sure you know how to do that. Step 1, find the LCD. Step 2, multiply both sides by that LCD. Great. Okay, this one we could do on Desmos too. Let's do it. So I see x in the denominator, so I know Desmos is going to give me a hard time if I do that. So I'm going to do it the old-fashioned way, and we're going to change all the t's to x's. So y equals 3 over x plus 1, and then y equals the right-hand side, 2 over x plus 3 plus 1/4. Great, so now I just have to click where they intersect, -5 and 5. And again, because it wants a positive answer, we would say 5. So yeah, even though this was a gritting question, and this was a hard question with a lot of work, you know, Desmos can help you make short work of this. Great, let's come back over here. Okay, this is a system. And I'm already noticing something kind of important. And that is this bottom one is like a hidden quadratic. I go over this a little bit in my factoring video, factoring in quadratic form. So that left side, you could pretend like, let's say x plus 1 is u, and you could make it u minus 4u minus 6, u squared minus 4u minus 6. You can factor that to adds to -4, multiplies to -6. So how about, I don't know, does that factor? What am I doing wrong here? Six and 1, does that give me -4? No. 3 and 2, does that give me 4 in any way? No. Maybe we need to substitute first. Let me go over here and just check. Yeah, this is not factorable. So I think we need to substitute first. So why don't we get y by itself in the top one? And then we can get started with that. So I'm going to subtract 3x from both sides. Y equals negative 3x minus 3. And now we're going to substitute that. So we get x plus 1 squared minus 4x plus 1 minus 6 equals y, which is negative 3x minus 3. And I wonder if we add the 3 over, will that work? Will that make it factorable? Negative 3. I wonder if that would work. I don't even know if that helps, though. You could just distribute all this and FOIL it out. It's just it would take a long time. Okay, negative 4 and negative 3. So adds to negative 4. I think that does work. Let's do that. So it should be negative 3. Is that factorable? I don't think it is. Yeah, that's not factorable either. I gotta see here if there's some way to leverage this. Give me a second. Okay, I see what I was missing. We have to rewrite this negative 3x minus 3. We need to factor out the negative 3. So you get negative 3 x plus 1. Now we can put that, we can add 3x plus 1 to both sides. And that gives us x plus 1 squared. Negative 4 plus 3 is negative 1, so it'll just be minus x plus 1 minus 6 equals 0. Now we can come over here and like make our little mental substitution. U squared minus u minus 6. And that should be negative 3 and positive 2. So negative 3 plus 2 gives you negative 1. Negative 3 times 2 gives you negative 6. Good. But now instead of u, we're going to put the thing in the parentheses, the thing that's kind of in the middle of our hidden quadratic. We talked about that in the Ottocento factoring video. So we're going to put x plus 1 minus 3, and then x plus 1 plus 2. And that becomes x plus 1 minus 3, that's x minus 2. And x plus 1 plus 2, so that's x plus 3. So if you do the zero product property, you should get x equals 2 and x equals negative 3. But you got to pay very close attention. The question's asking for y. So we need to plug these back in to the equation that was with our loaner variable, this one. So we're going to plug in 2. Negative 3 times 2 is negative 6. Minus 3 is negative 9. And then for the other one, negative 3 times negative 3 is positive 9. Minus 3 is 6. So it wants a positive value of y. Y is greater than 0. So our answer is 6. And let's see if that's right. Yes, great. Man, what a pain. I really missed that whole factoring out the negative 3. I didn't realize how important that was to the question. I mean, just like almost everything we've done so far, this one's way easier to do on Desmos. Any system, just do on Desmos. There's no reason not to. 3x plus y equals negative 3. X plus 1 squared minus 4x plus 1 minus 6 equals y. And there's 2 points of intersection, negative 3, 6, and 2, negative 9. So y is negative 9 and 6. We want the positive one. Positive answer for this one. Great. Okay, let's keep going. Which of the following has x-intercepts at negative 4 and 5? Okay, so I'm going to show you how to come up with this. So the x-intercepts, or the roots, are -4 and 5. So the factors are x minus the root. Factor theorem, x minus k, x minus the root. So x minus -4, which is x plus 4. And then the bottom one is x minus 5, which is just x minus 5. So it should have both of those factors. And the only one that has both those factors is a. We can verify our answer too by coming over here and typing in f of x equals x plus 4, x minus 5. And if we click on the x-intercepts, we see they are at -4 and 5. So we did a good job. Definitely understanding the factor theorem is really important because that could be crucial to another question. Also note that the question doesn't tell you a. So like really the function, if we didn't have any more information, would be a times x plus 4 times x minus 5. And then you'd have to plug in a point to solve for a. But this question is just kind of telling you, hey, don't worry about that. Like the answer choices, like a is 1 in all the answer choices. So they're basically telling you, just don't worry about that. But you might get another question where you have to worry about that. So I thought I'd bring that up. So don't forget to put an a in front. And don't just assume a is always 1 because that's not always true. It's true for this question, but. All right, great. Okay, if k is a constant, f of x equals k. Okay, so let's just sub out y equals f of x with y. So y equals k. So just look at this. And, you know, basically, so this is basically like y equals 1, y equals 0, y equals -1, y equals -2. These are all horizontal lines. Y by itself, and then a number, y equals number, is a horizontal line. So like left and right. So you now just have to draw each of these, which you can't really do on a digital test. But I think the only one where it's going to touch it 4 times is -1. Watch. So that's y equals -1. And you see how I got 1, 2, 3, 4. So I think that's our answer. I mean, geez, this is actually a pretty good, 14 is C, good. Okay, this is actually a pretty good one if they just didn't give you the equation. Because they gave you the equation, you can just start typing this stuff in. So let's do that. Okay, now I'm going to write f of x equals k. And, okay, k is 1. Okay, so it only touches it twice, there and there. Let's try k is 0. Seems like it touches it 3 times, there, and there. Let's try -1. Ooh, 1, 2, 3, 4. Okay, that looks good. Probably my answer. Let's try -2. Doesn't touch it at all. So, yeah, definitely Desmos is helpful for that question. All right, let's go back. All right, f of 2. So that just means make x2 in the function f. So I'm going to make x2, g of 2 plus 4. Okay, so now I kind of need to go and find g of 2. So let's go over here and do that. So g of 2 equals 2x, 2 times 2 plus 1. So g of 2, 2 times 2 is 4, 4 plus 1 is 5. So g of 2 is equal to 5. So we're going to come over here and put that in for g of 2. So f of 2 is equal to 5 plus 4. So f of 2 is equal to 9, and hopefully that is our answer. 9 is the answer. Function notation is really, really good on Desmos. It can even do when functions are calling on each other like this, as long as you give them different names. And I don't really care about the graphs. I'm going to type in f of 2, and it tells me 9. Desmos really helpful for this question too. Great, let's keep going. Okay, we've done ones like this a lot in the practice tests. First off, f of 37 equals 70. I would just write it as an ordered pair, just because people are more comfortable with that. So your x is what's inside the parenthesis, n. So I'm going to label the x with an n. And then your y is what's in front, what the name of the function is. So the thing in front is f. So that's our y. So I'm going to label that f. Okay, so now I just need to write down whatever the heck these things are. So, okay, so n is the nth day of 2016. Okay, so on the 37th day, I'm not even looking at the answer choices, guys. You don't need to. 37th day of 2016, and then f says, it says the function f gives the water level to the nearest whole percent of capacity. Okay, so 70% capacity, water level, something like that. Okay, so let's just see if there's an answer choice that's like that. So 70 capacity. These first two don't even have like the th, the nth day. So I think these two are just kind of wrong. And 70% capacity, 37th day. I think it's C. Let's see if that's right. Yep. Good. That's it. So again, let's kind of go over this again. First, change the function notation to an ordered pair, just because we're more comfortable with that. And the first number is your x, the second number is your y, so nothing crazy there. And then this is the important part that everybody messes up, okay? Besides going straight to the answer choices, which is kind of a trap. This guy is your x and this guy is your y. So label them accordingly. So x goes here and y goes here. So that's why we put n and then f. Lots of people might have thought the first thing was f and the second guy was n, but that's not true. Okay, great. Okay, this is like a proportion in equations. So it says the mass is halved and its speed is doubled. Okay, so we're going to do Ke nu is equal to 1/2 m. Instead of m, it's halved. So we're going to do m divided by 2. And then instead of v, we're going to put, and this is really important, you got to put in parentheses, it's doubled. So we're going to put 2v. Everything else stays the same. So see, I just replaced m with m halved, m divided by 2. And then I replaced v with 2v, and use parentheses, guys. If you don't use parentheses, you're going to get it wrong. Okay, so now our goal is to figure out the ratio, is to get these numbers that we just added out in front. And we don't care about the 1/2, just leave the 1/2 alone. So this is 1/2 times, okay, 2 squared is 4. 1/2 times 4 is 2. So we're going to put a 2 out in front. And everything else is the same. So this guy, there was no exponent, so we just pulled out a 1/2. And then this guy was 2 squared, so we pulled out a 4. 1/2 times 4 is 2. That's where that all came from. And now we can swap this out with the old kinetic energy formula. So notice how I deliberately left that 1/2 alone, because I didn't put the 1/2 there. The 1/2 was already there. If there's a coefficient already there, just leave it. You don't care about it. Okay, so Ke new is 2 times the Ke old. So it's double. Great. I guess it's C. That's right. Good. Another good way to do this is you could just come up with random numbers. So like make like m 10 and like the velocity 6 and see what you get for the kinetic energy, and then go and double and half it and everything. But I'm telling you, don't get reliant on that strategy. You got to make sure you understand the algebra that I just showed you, because you're going to see questions that are symbolic where this might be harder to figure out using numbers. I've already seen questions in the digital PSAT that pretty much force you to do this by hand. So make sure you know how to do this by hand. Great. Okay, literal equations. So we're going to underline in terms of, and whatever comes before, that's m2, we're going to get by itself. So the first things first, I got to get rid of that square root. So we're going to square both sides. And we get r1 squared over r2 squared, and then the square root on the other side just goes away, m2 over m1. And now, to get m2 by itself, we need to get rid of that m1. The m1 is being divided. The opposite of division is multiplication. So we're going to multiply both sides by m1. And these guys go away. And we are left with m1 times r1 squared over r2 squared equals m2. I just wrote it like that because the final answer is like that. I think it's answer choice A, which is correct. You could have also like combined the fraction and then put like this in just one numerator, m1 r1 squared over r2 squared. I don't know why they wrote it like that, honestly. Yeah, literal equations are really hard. It's going to be different every time. Notice how I'm always trying to like get rid of the farthest thing first. Okay, so it's like first I have to get rid of that square root because it's like kind of covering the whole thing. Then I get rid of the m1. If I were trying to get, say, like r2 by itself, I wouldn't care about the square root because the r2 is not under the square root. But notice how I circled m2 and he's under the square root, so I got to get rid of that square root at some point. Anyway, since the whole right side was under a square root, that was the first thing I did. All right, let's keep going. Okay, shows us constants or coefficients. The maximum possible weekly revenue. Okay, so it's quadratic. We want to know the maximum possible weekly revenue. So we have to find the vertex. So the vertex, from standard form, you can do h equals negative b over 2a. And then whenever you get for h, just plug in this case for p, and see what you get. Now, don't do any of that, because if you think about it, the form that shows the vertex is vertex form. Vertex form, which you should know by heart going into your test, is y equals a x minus h squared plus k. There's only one answer trace that even looks like that, right? It's got to be D. I don't even need to check the numbers. Do you see what I'm saying? It's like, so it's like if you know what vertex form looks like, if there's multiple options in vertex form, then you got to figure it out. But if there's not, you could just use process elimination. Like you just know that, okay, this is wrong. That's not vertex form. That's not vertex form. None of those guys are vertex form, so they're all wrong. So I'm going to leave the negative b over 2a to you guys because this video is getting super long. But we can verify the vertex. Let's do that. So r of p equals negative 4p squared plus 200p. And I'm going to zoom out here. It seems like the vertex, okay, so the selling price, the X, is 25, and the revenue, in this case, the maximum revenue, is 2,500. So the way you would actually solve this is figure out that the maximum possible weekly revenue is 2,500, and then you look at the answer choices and see, and the price that results in the maximum revenue. So you would figure out that the vertex is 25, comma 2,500, whether you do it by hand or on Desmos, and then look at all the answer choices to see which ones have a 25 and a 2,500. You see the only one that has a 25 and a 2,500 is answer choice D. Again, you kind of could shortcut it if you knew what vertex form looked like, which you should know. You really need to know vertex form. Great, let's keep going. Okay, drill 1. Okay, first thing I'm going to do, I'm going to distribute that first guy. So 2 times AB, that's 2AB. 2 times negative 3 is minus 6. And then plus 2. Negative 6 plus 2 is minus 4. So it should be 2AB minus 4, which is answer choice B, which is right. Okay, for this one, f of 20, we're just going to make x 20. So f of 20 equals 20 plus 0.25 times 20, and then times 50 minus 20. So that's 1/4 times 20. That's 5. So 25 times 30, which is 750, which for drill 2 is answer choice C. And I think this one's way easier on Desmos, so let's do f of x equals x plus 0.25x, 50 minus x. And now I'm going to type in f of 20, and it tells me 750. Great, let's keep going. Okay, so first thing, because I have x squared, x, and a constant, I got to get it all to one side. So I'm going to subtract 36 from both sides. And we should get x squared plus 6x. 9 minus 36, what is that? Negative 27. And now we're going to see if we can do factoring with a equals 1. So, I think it's 9 and negative 3. 9 plus negative 3 gives you 6. 9 times negative 3 gives you negative 27. Good. All right, now we're going to do the zero product property. X plus 9 equals 0. X minus 3 equals 0. We subtract 9 from both sides, we get x equals negative 9. We add 3 to both sides, we get x equals 3. And that is the answer. And of course, on the actual test, do not spend all that time doing that. Negative 9 and 3. We want the positive answer, so we're going to go with 3. F of 22. Okay, once again, we're just going to replace x with 22. So 22 over 22 plus 1. That's 22 over 23. That can't be simplified, so that is the answer. Absolutely zero reason to put in a decimal, because you could mess up typing in the decimal, right? But there's absolutely no reason to use the decimal, because Desmos will simplify fractions for you, but it won't tell you how to type a decimal into the Blue Book app. So you're probably more error prone to doing a decimal. Great, let's come back over here. Okay, so solution is just points of intersection where they both meet. So here and here. So there are two solutions. So that is answer choice C. And let's see for drill 5, that is right. Good, another literal equation. I've done this one many times. We got to get R, no, it says in terms of. So we have to get in terms of, so we have to get the radius R by itself. Okay, so I've got an exponent and I've got multiplication. Exponent comes last. PEMDAS, you're going to go kind of in, when you're doing algebra, it's not always this simple, but a lot of the time you can use the kind of like reverse of PEMDAS to help you figure out. So first we see if there's any addition and subtraction. There is not. Then we see if there's any multiplication division. Oh, okay, I'm multiplying by 4 pi. So we're going to divide both sides by 4 pi because the opposite of multiplication is division. So let's do that. Okay, this guy goes away, and we are left with s over 4 pi equals r squared. Okay, now we can move on to exponent. So you see exponent is one of the last things you should always do. And squared, so the opposite of a square is the square root. So we are going to square root both sides. And notice how I'm like being really particular to write out my algebra because there's no numbers. So it's like going to be hard for me to do in my head. So I don't want to do that. Okay, so the square root of r squared is r. And then this left side is just that big mess. S over 4 pi, all under a square root. And I think that's answer choice A. Let's see if that's right. Yeah, it is. Good. We don't need a plus or minus because this is a geometry problem. So radius can't be negative. So, okay, we didn't do one like this. This is not an equation. It's an expression. So, because there's no equal sign. So we can't use clearing denominators. We have to find a common denominator. So they already have x squared minus 1, right? So they have a 2 and 3. So the LCD of 2 and 3 is 6. So the LCD is going to be 6x squared minus 1. So for the left one, we have to multiply the top and bottom by 3 to get 6. And the right one, we have to multiply the top and bottom by 2 to get 6. So we get 12x over 6 x squared minus 1 minus 6x over 6 x squared minus 1. And now that we have a common denominator, we can kind of shove it together. So 12x minus 6x is 6x. So we get 6x over 6 x squared minus 1. And let's see, did I do something wrong here? I might have. Let me see. No, it looks good. We have a 6 on the top and bottom, so this guy goes away. And we're left with x over x squared minus 1. And that gives us answer choice D, which is correct. I'll do it really fast just for the correct answer. Remember, for equivalent expressions, you can guess and check. I have a Desmos video on this. Okay, so 4x over 2x squared minus 1 minus 3x over 3 x squared minus 1. And now if I type in x over, let's see if how it looks. Yeah, perfectly replaces. The blue perfectly replaces the red. If you type in the other answer choices, that won't happen. Great. Okay, we did good. Okay, drill 8. It says maximum profit estimated by the model. Okay, so whenever I have a quadratic, if I'm looking for the min or max, I look at the vertex. So the vertex is here. And to, just out of curiosity, you know, to get the x coordinate, you would average the roots. So 25 plus 55 divided by 2. So that gives you 40. So another question could totally test you on that. So make sure you know how to do that. It's in the middle, so you find the midpoint, you add them up, divide by 2. And it tells us the y value is 1400. The profit is the y value, so it's 1400. But it says here it's in thousands of dollars, so it's actually 1400 times 1,000. Which is 1,400,000. And that is answer choice D. So just pay very close attention, guys. If they asked us the number of board games, we'd probably have to do something with that 40. But because they asked us the profit, we have to, like the number of board games that achieves the max profit, that would be 40,000. But the actual maximum profit itself, that's the y value. So we put 1400,000. Great, we're doing really good. Let's keep going. Okay, system of equations. I've already got y by itself. I could just substitute right away. I'm thinking that is what I will do. So let's substitute this loaner variable. And I get x squared minus 28x minus x equals 30. And that is x squared minus 29x. And then if I move the 30 over, that's minus 30 equals 0. And now let's see if I can factor this thing. It's probably 30 and 1. So it adds to negative 29, so negative 30 and positive 1. So the two x values are 30 and negative 1 using the zero product property. And now we're going to plug it back into our loaner variable equation up here. And let's see, 30 squared minus 28 times 30. That's 60. And then negative 1 squared minus 28 times negative 1. That is 29. So there were two possible answers for this. You could have put 60, or you could have put 29. So systems are almost always easier on the calculator. So let's try this. Notice, guys, for linear quadratic systems, we don't usually eliminate. We're often going to substitute. In a linear system, you could go either way, but for a linear quadratic system, we tend to substitute. At least that's what I tend to do. Okay, so we've got a y value of 29, and we got a y value of 60. That is super, super helpful. Great, let's keep going. Okay, so I don't really care for that 4 being there. At first, if you want, you could multiply the whole equation by 4. That's not really going to, it's going to make the numbers kind of big, so I'm going to not do that. But when you have quadratics and they tell you about solutions, they're testing you on the discriminant. And I made a YouTube short about this, so I'm just going to kind of gloss over it. You can go watch that if you want in the YouTube short section. When we have one real solution, b squared minus 4ac has to equal 0. That's what they're testing you on here. It's just something you got to know. Okay, so you see, if I write like ax squared plus bx plus c, a is 9, b is 108, and c, which I will put in air quotes because it is a little different, is this entire thing here. So don't forget, it's not like 1/4 or c, it's the whole thing, c divided by 4. Okay, great. So we can put that all into our equation. So we get 108 squared minus 4 times 9. And then c is c over 4. And what the heck is 108 squared? That's kind of a big number. Uh, 1164. 4 times 1/4 is just 1. 1 times 9 is 9. So this would be 9c. I'm going to move the 9c over to the other side. And now I'm going to divide both sides by 9. And I get c equals 1,296. Because they gave you the answer choices, you could have guessed and checked on this one pretty easily. You could have either put it as an equation, or you could have put it as a quadratic. And then just remember that the solutions are the x-intercepts. That's what I'm going to do because I feel like that makes more intuitive sense to like the grander scheme of things. Okay, so c equals 0. Okay, that's 2 solutions. C equals 324. Okay, 2 solutions. 1296. See, it touches right there. So it has exactly 1 solution. It only has 1. Okay, let's try 11664. Okay, so it seems the graph is way up there. So it doesn't even touch the x-axis once. So that guy has no real solution. We want 1. So all the other answer choices either have no solution or 2. Regardless, definitely make sure you know the discriminant by heart. Okay, great. Okay, Cal measured the temperature of a cup. Okay, this is really confusing me. So the temperature of the hot chocolate was 185 at 6 p.m. Okay, so M and T. So X is our M, and then the function T is our Y. T. Okay. So, and it's minutes after it started cooling. So we'll say T is 0, that's 6 p.m. Sorry, T is temperature, not time. M is 0, 185. And then 5 minutes after it started cooling, at 6:05, it's 156. And then at 6:10, that's 10 minutes after, it's 135. Okay, great. Now I'm just going to do a quick inspection here. The X is changing by a constant amount, but I don't know if the Y is. Okay, so it first goes down by 29 degrees. Then it goes down by 21 degrees. Okay, so it does not have a constant rate of change, so it's not linear. So I don't see any linears in the answer choices, so it doesn't really help. This is probably exponential, and I'm going to be honest, it might be easier to just kind of guess and check. I feel like that's what most students would do here. So a times b to the x. It's really like a times b to the t over n because there's an interval. See how it's going up by 5? So there's an interval of 5. All these equations are so different. I'm not sure there's like really a good way to figure this out organically. I'm going to start guessing and checking. We'll come back to it. Okay, so if I plug in 0 for the first one, I get 185. Plug in 0 for the second one, I get 185. If I plug in 0 for the third one, I definitely do not get 185, so he's out. And if I plug in 0 for the fourth one, 115 plus 70, I do get 185. Okay, so now let's try plugging in 5. So 185 times 1.25 to the 5. Okay, that gives me a much bigger number. That's actually going up. So this guy's out. Let me try B. So 185, 0.85 to the 5th. 82. Oh, that's way too small. That's not 156. Okay, this guy's out too. I think it's answer choice D. Very tricky. If you want, you can plot all these on Desmos and then graph it just to make sure that it's right. That probably would have been the easiest way, honestly. But I think just plugging in, I think what's going to give people trouble isn't the figuring out which equation it is, it's translating the paragraph to a table. So you really got to practice that. Make sure you know what x is, what y is, put x, y in your table, and then do not mix them up. Because lots of people, they would have put like 185, 0, and that might have given you the wrong answer. Let's graph it just to see what this looks like. Okay, so we're going to make a table, and I'll call this guy M, and I'll call this guy T. And 0, 185, 5, 156, and 10, 135. And I am now going to plot T of M equals 70 plus 115, 0.75 to the M divided by 5. And it looks great. So it goes perfectly through all 3 points. So we did a good job. Great. Still think guess and check is probably the easiest. All these equations are so different. Okay, first thing I'm going to do is I'm going to square both sides. So, I get 5 times x minus k equals x minus k squared. And I'm kind of tempted to just leave this as a quadratic. I'm going to subtract 5x minus k from both sides. I get 0 equals x minus k squared. And you can kind of pretend this is like u squared minus 5u. So the greatest common factor is u. So we're going to pull out u, or x minus k. And we are left with x minus k, and then u minus 5. Okay, so we can use the zero product property, x minus k equals 0. So x equals k. And then x minus k minus 5 equals 0. So we add k and add 5, so we get x equals k plus 5. And it says k is a positive constant. So that kind of tells me that if k is positive, the bigger solution is going to be this second one, k plus 5. Think about it, right? If k is like 1, 6 is bigger than 1, right? So the right one is going to be bigger. So this is telling you the greatest solution is 12. So we're going to set that equal to 12. So k plus 5 equals 12. Subtract 5 from both sides, and we get k equals 7. And that is correct. I'm wondering if there's a way to do this. Let's see what we come up with. Yeah, I suppose you could just like keep kind of guessing and checking until you get 12. You could use the slider. If I plug in 9, I get 12, but I don't think that's the greatest. Is that the greatest solution? I'm not really sure why. Oh yeah, here we go. Yeah, 12. That's 7. Yeah, you can just play around with the slider. That would have been a good way to tackle this one. Definitely make sure you understand the algebra. Let's keep going. All right, for what value of x does it reach its maximum? Okay, this is kind of in like a quasi-factored form. So the easiest way to do this by hand is going to be to find the roots. So we're going to say each of these equal to 0. We get 5 equals, add 2x to both sides, divide both sides by 2. We get x equals 5 halves. That's one of them. And then we're going to do 14 plus 2x equals 0. And subtract 14, we get 2x equals negative 14. And we get x, divide both sides by 2, we get x equals negative 7. And to find the x coordinate of the vertex, we can add those up and divide by 2. So 5 halves, or 2.5, plus negative 7, divided by 2. That gives you negative 9/4. And we don't even need to find the y value because it just says for what value of x does it reach its maximum. So it wants the x value. If it said what is the maximum, then we would go find the y value. But we only want the x value for this problem. Also, the answer is negative 9/4. Again, you see factors, try to find the roots, and then average them. So add them up, divide by 2. For Desmos, we just put this in and click on it. So let's do that. 5 minus 2x, 14 plus 2x. And I'm going to zoom out, look at the top, click on it. And it tells me the x coordinate where it reaches its maximum is negative 2.25, which is the same thing as negative 9/4. Don't be afraid to use a decimal if it terminates. Like negative 2.25 is fine. But if it repeats, you probably want to use the fraction, almost always. Okay, if the length of the court is twice the width. Okay, so length is twice the width. So is means equals, so we can write L equals twice the width, 2W. And it says the area, by the way, this is on the reference sheet, the area of a rectangle is length times width is 162. Now, so we're going to substitute L because it's by itself. So we get 2W times W equals 162. That gives us 2W squared equals 162. Now we're going to divide both sides by 2. And we get W squared equals, I don't know what that is, 81. And now we're going to take the square root of both sides. And we should get W equals 9. And we don't need to put a plus or minus because this is a geometry problem. We cannot have a negative width. So that gives us answer choice A. Let's see if that's right. Yep. Very good. I mean, you could, go and set this up as a system on Desmos, but I don't know. It's probably more trouble than it's worth. You still have to come up with the equations. They don't give you the equations. Okay, great. Another system that I'm going to do by hand. Okay, so they already gave us one of the letters by itself, so we can just substitute that into the other equation. I'm also going to put a box around this because, the loner equation is kind of important later. So we're going to put him in there. And we get x squared equals 6x plus negative 6x plus 36. I don't really need those parentheses. I can just kind of rewrite that as 6x minus 6x plus 36. That gives me 6x minus 6x is 0, so that gives me x squared equals 36. I take the square root of both sides, and I get plus or minus 6. So we have negative 6, and we have positive 6. We're going to go and plug those into our loner equation, which we were talking about before. Negative 6 times negative 6 is 36. 36 plus 36 is 72. 6 times negative 6 is negative 36. Negative 36 plus 36 is 0. Now it wants us to find x times y, so that's just multiplying them together. Negative 6 times 72 is negative 432, and 6 times 0 is just 0. Seems like the only one that we got is A. Great, let's do it on Desmos. So x squared plus 6x, no, equals 6x plus y, and y equals negative 6x plus 36. And now I can just click on the points of intersection. Okay, so 6 comma 0, so 6 times 0. That gives me 0. Okay, let's try the other one. Negative 6, 72. That gives me negative 432. Great, so that was a really hard question, but would have been much, much easier using Desmos. All right, let's keep going. Okay, so first off, it says A is an integer, so whole numbers, positive or negative, including 0. Negative 3, negative 2, negative 1, 0, 1, 2, 3, etc. It says it's got to be between 1 and 4, but there's no equal to, so it means not including 1 or 4. So that only gives you 2 options, 2 or 3. So A could be 2, or A could be 3. So we're going to solve the problem for both those. Okay, so now it also tells me that 11, 0, and negative 2, 0. Okay, so let's put this off to the side because I don't think I'm going to need that much space. Remember I was talking about this before, guys, with the x-intercepts? You can find the vertex kind of quite easily by adding them up. So the x-coordinate of the vertex, s plus t divided by 2. So 11 plus negative 2 divided by 2. That's 11 plus negative 2. 9. 9 divided by 2. I'll just use a decimal for the sake of simplicity. 4.5. So h equals 4.5. Now, I don't know all these coefficients, so I can't find k. But there's another way to find h that we can relate. So we can relate h and a to find b. So the equation, this is also really important that you know, is negative b over 2a. So we're trying to find b. So why don't I do a literal equation and solve for b? So I'm going to multiply both sides by 2a. I get 2a h equals negative b. And now I'm going to multiply both sides by negative 1. And I get b equals negative 2ah. Okay, so now I can really quickly find b for each of these. So negative 2 times a is 2 for that one, times h, which is 4.5, gives me negative 18. And then for the other one, negative 2 times 3 is a, and then h is still, for both of them, 4.5, negative 27. And they want us to find a plus b. So the sum (2 plus negative 18) is negative 16. And 3 plus negative 27 is negative 24. So either of those answers would be acceptable. So do you guys see, like, knowing the equations to find the vertex is actually surprisingly important on the DSAT. And sometimes you might even have to rearrange them a little bit. You certainly didn't have to rearrange them, but I think getting b by itself first made the rest of the problem a lot easier. That's just what I think personally. I suppose to figure this out, you could do a bunch of graphing and regressing on Desmos, but I actually think it would be a lot of work and it would not help that much. So I would definitely do this one by hand. These two concepts, h equals negative b over 2a, and that the x-coordinate of the vertex is the midpoint of the roots, those are two really important concepts you want to make sure you know by heart. Okay, that was the last one. Okay, that completes the lesson. Please like and subscribe for more digital SAT math content. If you're interested in my tutoring services, the link to my website will be in the description. I tutor SAT math and all math subjects from about 7th grade to AP/early college level. Thanks for stopping by, and good luck studying.